Last section in Unit 6. This is Learning Target 6C, Systems of Linear Inequalities. By the end of this lesson, you will be able to determine whether or not an ordered pair is a solution of a given system, as well as solve a system of linear inequalities by graphing. So our first definition is, well, what is a system of linear inequalities? A system of linear inequalities is made up of two or more linear inequalities. In our last section in Learning Target 6B, we learned how to solve a single linear inequality. And as a quick reminder, that's when we were to graph our boundary line. We could either have a solid or a dotted line depending on what type of inequality we had. So if we had a greater than or a less than, we would have had a dotted line. We would graph it using the slope and the y-intercept. If we had a less than or equal to or a greater than or equal to, then we would have graphed that line using a solid line. Again, we're graphing those lines using the slope and the y-intercept. From there, we picked a test point, and we use that test point to determine if we shade on one side or on the opposite side. And as a reminder, if the test point was true, then that means that we shade where the point is. So we shade with the test point. If the statement was false, then we would shade on the opposite side of the test point. So we said that that was shading opposite the test point. And our whole solution was whatever section of that was shaded. So in this first graph, maybe it was shaded above, or maybe in the second graph it was shaded below. But our graph was our entire solution for that, since the shading represents all of the solutions for that singular linear inequality. What we're looking at now is pairs of linear inequalities. So a system is two or more. In this video, we're going to look at what happens if I pair two of them together. And a solution for a system of linear inequalities is the ordered pair that makes all the inequalities in the system true. So what we're looking for is the solution set is where the overlap shaded region is. What we're going to do before is ultimately take two of those problems that we had done in the last section and just put them together on one graph. And our final answer will be where their shading overlaps. So how to solve a system of linear inequalities? Our first step is to solve each linear inequality individually like we did in Learning Target 6B. But what we're doing now is we are graphing them on the same coordinate plane. The reason being is we want to see where their answers overlap, because a solution is what makes both of the linear inequalities true. So our final answer will be where the double shaded region is. Let's look at our first example. Our example here says solve the following systems of linear inequalities. In example 1, our system says y is less than 2x minus 3 is our first line. And our second line is 2x plus y is greater than 2. I am going to color code both of these lines so we can see how each system is individually graphed, and then together what we're looking for is where the purple and the blue overlapping region will be. So for this first line, we need to figure out what our slope and our y-intercept are. Why don't you guys pause the video and determine what your slope and your y-intercept is. Our slope for this line is going to be 2. Our y-intercept is going to be 0, negative 3. And I now have enough information to graph the line, but before I start graphing the line, I need to ask myself if this line will be solid or dotted. What do you guys think? Is this graph going to end up having a boundary line that is solid or dotted? In this case, we're going to have a dotted line. And remember, that dotted line is based off of what the inequality is. So if we have a less than or a greater than, it will be a dotted line. If we have a less than or equal to or a greater than or equal to, that would produce a solid line. So for this first line, we're going to go down to 0, negative 3. From there, our slope tells us to go up 2 and to the right 1, up 2 and to the right 1. But I have enough points now to draw my straight line, so I'm going to go ahead and draw a dotted or a dashed line through these as it keeps going up. Of course, if you have a ruler, that might be a great idea to use a ruler right now. Now from here, before I even graph the other line, I'm going to test a point for the purple line and figure out where the shading will be. In our last video, we tested the point 0, 0 because it's an easy point to test, but most importantly, it is not on the boundary line. So in this case, 0, 0 is not on the boundary line, which is our purple dashed line there, so I am allowed to test it. To test it, remember we're subbing it into the inequality. So I'm starting off with the inequality that says y is less than 2x minus 3. When we sub in 0, 0, I'm asking myself the question, is 0 less than 2 times 0 minus 3? That's what we're trying to figure out if we get a true or a false statement there. When we simplify this, we get 0 less than negative 3. Is that going to be a true or a false statement? Is 0 less than negative 3? In this case, it is a false statement, which means that we will shade on the opposite side as our test point. So I'm going to shade on the opposite side of my test point. Since our test point is at 0, 0, where I have that red X, I cannot shade where 0, 0 is since this statement was false. Instead, I'm going to shade on the opposite side. Instead of coloring it in right away like I did in the last video, I have to worry about my other line as well, so I'm just going to draw myself some reminder arrows here that the shading would go down or be on the right side of this graph. The reason I don't want to shade it in completely is I have to still graph this line, so I want to make sure I can see my coordinate plane all the way. And we'll worry about the overlapping shading at the end. Let's look at our second line. We have 2x plus y is greater than positive 2. We need to be able to graph this line, so we need this in slope-intercept form. Why don't you guys pause the video, write this inequality in slope-intercept form, and then find the slope and the y-intercept. To get this line into slope-intercept form, we need to subtract 2x over. That will not change the inequality sign, so we end up with y is greater than negative 2x plus 2. Our slope is going to be negative 2, and our y-intercept is going to be at 0, positive 2. I now have enough information to graph, but I first need to remember if this line will be solid or dotted. What do you guys think? Will we have a solid or a dotted line? For this one, we're also going to have a dotted line because I have an inequality sign that does not have an equals to bar, so I just have the greater than sign. We're going to start at 0, positive 2, put a point. From here, my slope says go down 2 and then to the right 1, down 2 and to the right 1. I can use my ruler now and draw my dashed or my dotted line as this keeps going. Whoops. I want to make sure it stays dash, so make sure I have some separation in between those. From here, I'm going to go ahead and test a point to figure out which side of the blue line I'm shading. So right now, as I'm graphing the blue line, I'm ignoring the purple line because the solution to this blue inequality has nothing to do with the solution to the purple one that we already solved for. So we are solving them individually, we're just graphing them on the same coordinate plane. I can go ahead and test 0, 0 as well, since 0, 0 does not run through my blue boundary line here. When I sub that in, I'm going to go back to the original, and I'm asking myself the question, is 2 times 0 plus 0 bigger than 2? To figure this out, I'm going to simplify the left-hand side, and that will be 0. So we're asking ourselves the question, is 0, bigger than 2? Is that a true or a false statement? This is also a false statement since 0 is not bigger than 2, which means, again, we have to shade on the opposite side as the test point. So because our test point was 0, 0, I don't want to shade below the blue line. Instead, I'm going to shade above the blue line. So I'm going to draw myself 2 arrows to see that as well. I'm now going to also start sketching in a little bit of this shading so we can see what this would look like. I'm not going to color it in too much because I want to make sure I can still see the other line. So we're above the blue line and we're to the right of the purple line. Now our final answer is going to be where I have the 2 colors that are overlapping. So it's where I have both the blue and the purple shading. So our final answer here, I'm going to actually shade it in red, is going to be this whole section right here that is to the right of the purple line, but still above the blue line, since that's where the overlapping is occurring. And just like in our last section, our graph with the shading and the slopes and the y-intercepts with the solid and the dotted lines is actually our final answer. And there is our first example. What I am going to start doing in the rest of the examples is I'm just going to draw these arrows to show me what direction I would shade, and then I'm going to just end up shading my final answer versus shading both the blue and the purple separately. The reason I suggest that you do that is so that it's easy on a test to make sure that you can really see what your final answer is. If you don't have two colors and you're just shading everything in really dark, then it looks like you're saying that this whole section up here as well as this section down here is all part of your solution. But in fact, the only part of my solution here is what is shaded in red. So for the rest of the examples, I'm just going to shade in my final answer so that it's clear what our final answer is. All right, let's look at example 2. So in example 2, we have y is greater than or equal to negative x plus 5. Why don't you guys pause the video, graph this line, and figure out where the shading would occur and just kind of draw yourselves these arrows again that point in the direction that we would shade. Okay, let's check this one together. So I am in slope-intercept form, so I can see that my slope is negative 1, and my y-intercept is going to be at 0, 5. We have a solid line this time since I have the equal to bar there. So I have that greater than or equal to. So we will start at 0, 5, put our point there, and from here I'll move down 1 and to the right 1 since my slope is negative. I'm going to go ahead and insert our straight line for us so that we can see it since it will be a solid line. And I want to make sure, again, that this is extending across the entire graph, and I'm not really sure where the other one is going to come into play, so I'm going to extend it even a little bit extra just so that I can make sure that I can figure out where they intersect once I draw the purple or the blue line. From here, I need to test a point so I can figure out which side of that line I am shading on. I can go ahead and test 0, 0, since 0, 0, I'll put that red X there, is not on the boundary line. So as long as 0, 0 is not on our boundary line, we can go ahead and use it to test. I'm subbing it into our first inequality right now. So I'm asking myself the question, is 0 bigger than or equal to negative 0 plus 5? Reducing this down, I'm really asking the question, is 0 bigger than or equal to 5? This is also a false statement, which means that I have to shade opposite the test point. So far in our example, all of these that we tested came out to be false statements, which is why we're shading away from 0, 0. So I will be shading up through these. I'm not going to color it in just because I want to make sure my final answer is clear. Okay, I'm going to do our second line in blue. So we have negative 3x plus y is bigger than negative 4 was our original problem there. Why don't you guys pause the video and graph this linear inequality. So to graph this linear inequality, I have to first change it into slope-intercept form. So I'll add the 3x to the other side and get y is bigger than 3x minus 4. I can see then that my slope is going to be 3 and my y-intercept will be 0, negative 4. I can go ahead and plot that. I'll be at 0, negative 4. Then from here we'll go up 3 and to the right 1, up 3 and to the right 1. But before I go in and I graph it, I want to check and see if it's a solid or a dotted line. In this case, this will be a dotted line since I have a strictly greater than inequality. So I'm going to go ahead and make this line dashed. I could use a ruler to do this, and again, I'm going to keep extending it just so that I can see everywhere it intersects. The last thing I have to do with just the blue line is to test a point. I can test 0, 0 since it doesn't intersect the boundary line. Subbing that in, let's write down our original, whoops. That was supposed to be a negative 3. So our original inequality says negative 3x plus y is greater than negative 4. So subbing in 0, 0, we get negative 3 times 0 plus 0. And we're asking ourselves the question, is this bigger than negative 4? Simplifying it down, I just get left with 0 on the left-hand side. So we're asking the question, is 0 bigger than -4? This is actually a true statement now. And if I get a true statement, it means that I shade where 0, 0 is. So I shade with the test point this time instead. So because the test point was true, I will shade wherever that point is. So I will be shading to the left of this. So where is our final overlap region? Is this kind of first section up here? Is it the second section, this third section down here, or this fourth section? What do you guys think? Where is the double overlap gonna be? So the double overlap is gonna be in our first section up here. So I'm gonna go ahead and erase those reference numbers. The reason it's in the first section is because I have both the blue line pointing up, so I have this part that is shaded, and I also have the purple line going in as well. So our final answer is where those two colors are going to overlap. So I'll shade that in with both the blue and the purple so we can see it. I would suggest that you only shade your final answer in these so that it's clear that that is your final answer versus having all of this shaded and then it's kind of unclear which one you really mean. Okay, let's look at example 3. So in example 3, our first inequality says y is greater than or equal to -3x plus 1. I think you guys should pause the video and graph this one on your own first and determine which direction you would shade. To graph this, we'll need the slope, which is going to be -3. We also have a y-intercept, which is at 0, 1. This will be a solid line since there is the equal to bar. So we'll start at 0, 1. And then from here we'll go down 3 and to the right 1. 1, 2, 3, yep. Since it's a solid line, I'm going to go ahead and insert a graph again. So we end up getting this line going straight. Oops. Make sure I extend it. I want to make sure it extends all the way and that it reaches through both of those points. I'm going to make it a little bit darker thicker so that we can see it. So there is our first line for the top inequality. I have to figure out which way it's going to shade. So I need to test a point. Can I test 0, 0? So I can actually still test 0, 0 because although it gets kind of close to it, 0, 0 is right there and it does not actually go through 0, 0. So if I test 0, 0, we're subbing it in to the original and we're saying is 0 bigger than or equal to -3 times 0 plus 1. So that's asking, is 0 bigger than or equal to 1? Is that a true or a false statement? This is going to be a false statement, which means that I will shade opposite 0, 0. So my shading would go up. Again, I'm just going to draw my kind of arrows to remind me later on after I have the second line drawn. Okay, let's graph the second one. The second inequality says y is less than -3x plus 4. Why don't you guys pause the video and graph that line as well? Is there anything you guys noticed when you graph this line with our two lines here? What I noticed is that I'm going to have lines that are parallel because I have the same slope. So our slope of the second line is also -3, so that's okay. The lines aren't going to intersect, but we could still have a solution. So I have a y-intercept this time of 0, 4, and in this case I do have a dotted line since I have strictly a less than inequality. So starting up here at 4, I'm going to put a dot, and I'm going to go down 3 and to the right 1, down 3 and to the right 1. So these lines are close together, but they're actually not intersecting. They are parallel lines. I can draw my dashes as they keep going. And it's okay that they don't intersect because my solution for these doesn't really have to do with where the lines intersect. It has to do with where the shading is overlapping. So let's go ahead and test our point. I can test 0, 0 since that is not intersecting the origin. When we substitute it in, let's rewrite the original so we have it as a reference. We get 0 less than -3 times 0 plus 4. So we end up with 0 less than 4. Is that a true or a false statement? So in this case, this is going to be a true statement, which means I want to shade towards 0, 0. So because 0, 0 is underneath the blue line, that means I'm actually going to shade down. So where would our final overlapping be on these two graphs then, if I have to be above the purple line but below the blue line? So my final overlap is going to be in between the two, and I'm going to go ahead and I'll shade it in both purple and blue. So I'll have both of this that is above the purple line but below the blue line. So it's all of that that's overlapping. Although the lines themselves never intersect, that's okay. Their shading does, so there is a place where I do get a solution set. Let's look at our last example here. So the first line, or first inequality, says y is greater than 1/2 x minus 3. I want you guys to pause the video and graph that line on your own first, and then also figure out where the shading will be. When we graph this, I have a slope that is equal to 1/2. We have a y-intercept that's going to be equal to 0, -3. The other thing I have to worry about is the fact that this is going to be a dotted line. So it does make a difference if you draw the line dotted versus solid. Remember, this is dotted because I have the strictly greater than. So I'll start down here at 0, -3, go up 1 to the right 2, up 1 to the right 2. That will be enough to get my line, so I'm going to go ahead and dash my line. This keeps going down this way, and it's dotted again because I have a strictly greater than. I need to now test a point. I can test 0, 0 again because 0, 0 is not on our boundary line. When we sub that in, if I rewrite the original problem for us, we get 0 bigger than 1/2 times 0 minus 3, and we're wondering if that is true or false. Simplifying it down, we get 0 bigger than -3. Is this a true or a false statement? This will be a true statement. So if I have a true statement then, does that mean that I shade where the test point is, or do I shade opposite where the test point is? This means I'm going to shade where the test point is. So because 0, 0 is above the line, since our test point was true, it means that we are going to end up shading above this line. So as I want to shade where the test point is. For our second inequality, we have y is less than or equal to -2/3 x plus 4. For us to go ahead and graph this, why don't you guys pause the video and graph it on your own first. To graph this guy, I need my slope, which will be -2/3. We also need our y-intercept, which will be 0, 4. And the last piece of information we need before we graph it is to remember that this will be a solid line because there's the equal to bar. We'll start at 0, 4, put our point. From here, we go down 2 and to the right 3, down 2 and to the right 3. I do get a solid line, so I'm going to go ahead and just insert that straight line for us. And I want to make sure that I'm extending it so that I can see where these are intersecting, because I might have part of that as my answer. Oops. From here, our last step is to test a point that is not on the boundary line to figure out which way we shade. We can test 0, 0. So I'm going to go ahead and have us test 0, 0, rewriting the original problem for reference. Subbing in 0, 0, we get is 0 less than or equal to -2/3 times 0 plus 4. Making sure we have enough space here. That will reduce down to 0 less than or equal to +4. Will that be a true or a false statement? This is going to be a true statement. So if I have a true statement, does that mean that we shade where the test point is, or do we shade on the opposite side of the test point? If the statement is true, that means we shade where the test point is. So that means I want to shade below this blue line. Then for our final answer, what are we looking for? What will our final answer be here? So our final answer in these is where the two shadings overlap. So it's going to be this section right here, since I have both the blue line shaded down, and then I also have the shading above the purple line here. So it's that big kind of pizza slice that we're getting right there. This is our last example in Learning Target 6C. So in this example, we took our Learning Target 6B and put two of those problems together. So we are now solving a system of linear inequalities, which means our final answer will be where the two shadings overlap in these problems. So as we can see in this last example, it's where both the blue and the purple shading overlap. Now I'm only shading in my final answer so that it is clear that my only answer I get here is just this region and this section.